Hello all. Today we are going to discuss K-means algorithm with the help of an example. K-means algorithm is used for unsupervised machine learning and it is a partitioning based method where clusters are formed based on distance matrix. So we will be using a distance matrix to form clusters. Okay. So these are the steps for K-means algorithm. We will discuss these steps with the help of an example. Okay, so let us take one example and we will discuss the steps with the help of one example. So for K-mean algorithm, how many clusters we want to form is a very important criteria. So we need to know how many number of clusters we have to form, and the number of clusters will be our K, right? So K will be the number of clusters. So if we want to form two clusters, our K will be equal to 2. Okay, so let us take this example to form clusters using K-means algorithm. We have been given a data set with 10 students, and for each student, marks for math and English are given. Okay, and we have also been told that we have to form two groups, that is two clusters from this given data set, right? So first step would be Our first step would be to find out or identify what should be our K. Now, in our problem, we have been told that our K, we have to form two groups, that is two clusters. So, we will take our K equal to 2, right? After we have taken k equal to 2, we need to randomly select two different means for these two clusters, and these two means are randomly selected. So let us select these two means as M1 and M2, where M1 is 4 comma 5 and M2 is 7 comma 6. So here 4 comma 5, this is for maths, this is for English, and this is for math, and this is for English. And once again, these 2 points are randomly, these two means, they are randomly selected, right? Now, our second step would be to find out the distance between the given sample point from mean M1 and mean M2. Okay, so we will find out how far is each sample point in the data set from mean M1 and from mean M2. And to find out this distance, in this problem, we are going to use a metric called as Euclidean distance. But we can use any other metric to find out the distance between the two points, right? We are using Euclidean distance. We can also use Manhattan distance, right? So what is the formula for Euclidean distance? If we want to find out distance between any 2 points, okay, so if there are 2 points here and I have my coordinates as x1, x2 and y1, y2 for these 2 points, then the Euclidean distance between these 2 points will be x1 minus y1 the whole square plus x2 minus y2 the whole square and root of this. This is the formula for Euclidean distance. Okay. So we have 10 students here, and for 10 students we have marks for math and English. So we have to find out distance of this data for student 1 from M1 and from M2. Okay, so distance of the first student from M1 will be, I will be using this place to find out the distance. It will be math marks minus the first element in M1, that is 4, the whole square, plus English marks minus the second element of this M1 here, which is 5, the whole square, take the root of it. Okay, so if you calculate this, you will be getting 2 minus 4 the whole square, which is 4, plus 1 root of this. If you take root of this, you will get 2.236. Okay, so that is the distance of the first sample point with 2 comma 6 elements, element as 2 comma 6 from M1, that distance is 2.236. Similarly, we can find out the distance of the first student with coordinates 2 comma 6 from M2, and after calculating or after using this Euclidean distance formula we will get this distance as 5.385. This process or this procedure we have to do for all the students here, for all the 10 sample points that we have here, and we have found out the respective distances from mean M1 and from mean M2. All right. Now let us go to the next step. Okay. So now we have to identify which distance is lesser. So if we take the first sample point of first student, whether the first sample point is nearer to M1 or whether it is nearer to M2. So if the distance between the sample point and M1 is less, then the sample point is nearer to M1, cluster 1. Otherwise, it is nearer to M2, which belongs to cluster 2. All right. So, if D1, which is the distance from M1, if that is greater than D2, which is distance from M2, we assign that sample point to cluster 2 because that sample point is nearer to mean M2, right? Otherwise, we assign that sample to cluster 1. So here we have done assignment of the cluster. So distance, if we take the first student here, if we see this distance M1, it is lesser than the distance M2. So we can say that the data of the first student belongs to cluster 1 because the distance of the data of the first student is nearer to M1, okay, or lesser than M2, distance from M2. All right, so we have done the cluster assignments here. Now let us go to the next step. Now, according to this cluster assignments that we have here, student 1 and student 5, that is sample point 1 and sample point 5, belong to cluster C1, and sample point 2, 3, 4, 6, 7, 8, 9, and 10, they belong to cluster C2. Okay, so we have given or assigned each sample point to some cluster, which is this, right? So cluster assignment is done in this step. Now, for each cluster, let us find out the new mean. So earlier the means that we had taken, M1 and M2 that we had taken, were randomly selected. Okay. Now, based on the new clusters which are formed, we have to find out mean for each cluster. So we will be taking sample point 1 and 5 for cluster 1 and the remaining sample points for cluster 2, and we will find out the mean, right? So for sample point 1, the coordinates are 2 comma 6. For sample point 1, the coordinates are 2 comma 6. For sample point 5, the coordinates are 6 comma 5, right? So our new mean M1 will be 2 plus 6 upon 2, comma 6 plus 5 upon 2. This will be our new mean, which is equal to 4 comma 2.12. Okay, so this is our new mean M1. Similarly, we can take the mean of the remaining sample points which are there in C2 and we can get M2. So what are these values? 4, 10, 9, 7, 8, 5, 5 and 6. These values are math marks for these students. And these values here 10, 8, 9, 6, 5, 9, 7, 8, these are the values of English marks for these students in cluster 2. Okay, so we find out two different new means M1 and M2 based on the clusters which we have just found out. Okay, and again we will repeat the same process of finding distance of each sample point from these means, new means that we have calculated from M1 new and M2 new. So we find out the distance of student 1 from M1, that is new M1 that we have here, and we also find out the distance of student 2, sorry, this thing, yeah, from student 2 of student 1 from new mean M2. Okay, so these are the distances that we have found out, right? And again, we will do the cluster assignment. So these are the distances that we have found out from the new means M1 and M2. In this slide, these are the old distances which are given. Okay, these are not the calculated new distances. New distances we are going to find out in the next slide. So these are the distances that we have calculated from the new mean M1 and M2. Okay, so 2 comma 6, how far it is from 4 comma 2.12. If we take the Euclidean distance, we get 4.367. And similarly from M2, how far is this point 2 comma 6? It is 5.062 units, right? So these are the distances that we have found out. And in the next step again, we will see which distance is less, and accordingly we will assign the clusters. So for student 1, distance D1 is less than D2. So we assign student 1 to cluster 1. But for the remaining students, we can see that distance D2 is lesser than D1. Hence, they are assigned to cluster 2. So if you notice, in the first iteration, we had student 1 and student 5 in cluster 1. But after getting the new means, finding out new means M1 and M2, the cluster assignment has changed. So this is the second iteration, results of second iteration. Now for the third iteration again, we have to find out M1 and M2 based on the sample points which are there for cluster 1 and cluster 2, right? But after doing one more iteration, we will observe that the clusters are not changing. The cluster assignment is not changing. So if the cluster assignment is not changing, or if the means that we find out they are not changing, we can stop there. Okay, we can stop the iterations, and that will be our final cluster assignment. All right. So let me just quickly go to my first slide where we had given the steps. So these are the steps here. These are the steps. So we determine the number of clusters that we want to form. We find the distance. We randomly select k different means for k different clusters. We find the distance of each sample point from these k different means, and then whichever is the minimum distance, whichever mean is giving you the minimum distance, we assign the sample point to that particular cluster. And once all the sample points are assigned, we find out new mean value for each cluster, and we repeat these three steps once again till there is no change in the value of means, or there is no change in the cluster assignment, right? So this was the k-means algorithm with the help of an example. Thank you.